Hello and welcome to the class on chi-square test. The Karl Pearson's chi-square test is used where observed frequencies are to be tested against their expected frequencies. In this case, the test is known as chi-square test for goodness of fit. The test can also be used to test whether two factors or characters or attributes are independent or not. Here, the test is referred as chi-square test for independence of the attributes. The test statistic for goodness of fit is obtained with the formula x square is equal to summation O minus E bracket square divided by E. Chi-square value. The steps involved in chi-square test for goodness of fit include setting up the null hypothesis as the fit is good, which means that there is no significant difference between the observed and expected frequency. Preparation of a chi-square table based on the observed and expected frequencies. The degrees of freedom is obtained by taking number of rows minus 1 multiplied by number of columns minus 1. The conclusion is finally drawn by comparison of the calculated chi-square value with the table chi-square value. Here are a few examples of chi-square table. Female and male progenies in the expected ratio of 1:1, where the chi-square value is computed as 6.76. In case of phenotypic ratio of the monohybrid cross progeny, where the expected frequencies are 3:1. In this example, the chi-square value is computed as 7.41. In case of genotypic ratio of monohybrid cross progeny, where the expected frequencies are 1:2:1, the chi-square value in the given example can be obtained as 4. Similarly, the chi-square table can be proposed for dihybrid cross phenotypic progenies which are about to be expected in the proportion of 9:3:3:1. In this example, we can obtain the calculated chi-square value as 13.76. The calculated values are to be compared with the table chi-square values. Here, we can observe one example of location of a table chi-square value at 4 degrees of freedom and at 5% level of significance. If the calculated chi-square value is less than table chi-square value, we say that the observed frequency is non-significantly different from the expected frequency. The null hypothesis is therefore failed to be rejected. If calculated chi-square value is more than the table chi-square value, we say that the observed frequency is significantly different or highly significantly different from the expected frequency, and we therefore reject the null hypothesis. The chi-square test for independence of attributes is performed in order to test whether there is any association between the two attributes. The attributes are nothing but the factors or the qualitative characters, such as sex of the individual and the horn pattern, or sex of the individual and the eye color. For the test of independence of attributes, the data is presented in the form of a contingency table. A table giving simultaneous classification of the body of data in two different ways is known as a contingency table. Initially, the null hypothesis is set as the two factors or the characters or attributes are independent of one another. That is, there is no association between the two characters. The contingency table is prepared as shown over here, where factor 1 is categorized in two levels A and B, and factor 2 is categorized in two levels, level 1 and level 2. This is an example of a contingency table where the horn pattern is categorized as horned and polled individuals. Similarly, the sex is categorized as females and males, and the number of respective individuals is denoted in the corresponding cells. The expected frequencies are computed with the formula row total multiplied by column total divided by grand total. Next step is to calculate the chi-square value and compare the calculated value with the table value. This slide shows computation of the expected frequencies within a given cell. These two tables denote the observed and expected frequencies in case of a contingency table. The chi-square value is then obtained with the formula summation O minus E bracket square divided by E. The conclusions will be drawn by comparison of the calculated chi-square value with the table chi-square value, as we have compared this value in case of chi-square test for goodness of fit. If we have a 2 by 2 table, then we need to use Yates correction factor, which is nothing but subtraction of 0.5 from the absolute difference in each O minus E combination as shown over here in the given formula. The assumptions for conducting chi-square test are that we should use only the frequency data. We cannot use the derived variables. All the observations must be independent and mutually exclusive. Number of observations must be large. A minimum expected frequency of 5 is necessary in each O minus E combination, and Yates correction factor needs to be used when we are dealing with a 2 by 2 table. The chi-square test for goodness of fit can be applied in genetics or while testing the distribution frequencies of binomial Poisson and normal distribution. The test for independence of attributes can be used to compare whether the observed and expected frequencies between two attributes are independent or dependent on each other. Thank you.